Hello, my name is Shihab Karar, and today my team and I will be talking about a book review for Chapter 10 in SLP 3 book, which is regarding information extraction. Now, to begin with, I will be talking about the ways the input type varies in all sorts of information extraction. Now, there are three main input types: unstructured, semi-structured, and structured. In unstructured, input types include news stories, magazine articles, and books, while semi-structured includes emails, shop posts, ads, and resumes. And for information redundancy, we have two types, which is a single document versus multiple documents. Now, a single document can extract specific information from each document and therefore process it, while multiple documents will allow for several opportunities to find one single piece of information again and again, and consolidating this information from multiple sources can be quite challenging. So, essentially, all of these together pose different sorts of challenges and different opportunities also at the same time to the to how we input and manage data for information extraction. Thank you.
IE systems can be also classified based on the method they employ for performing the extraction task. Generally speaking, IE methods can be classified into handcrafted and learning-based approaches, slightly different. One can also categorize these methods into rule-based and statistical-based methods. Well-known examples of rule-based approaches are IE systems that employ finite-state transducers, but often based on handcrafted regular expression patterns. Learning-based approaches use statistical techniques and machine learning algorithms to automatically create IE systems for new domains or tasks. From this perspective, I system can be further classified into four categories based on the automation degree in the development process. That are systems that need programmers, systems that need annotation examples, annotation-free systems, and semi-supervised systems. Recent methods in IE combine a loose mixture of text extraction and data mining. Categories are mainly refers to methods that leverage whatever limited structured information is available and then use data mining techniques that are robust enough to operate directly on the raw text associated with this limited structure. Finally, IE methods can be classified by the type of their output. This categorization takes into the consideration the structure of output by IE systems. The extraction target can be in a range of isolated phrases to complex M tuples. In its simplest form, an IE system populates a list of homogeneous items. A list of the names of companies, such as extracted by named entity recognition systems. In the M-tuple extraction task, where M is the number of attributes in a record, the output has a more complex structure. Lastly, a more challenging IE task is to automatically induce the extraction templates and then populate them. Extraction is the task of extracting semantic relationships from text, which usually occur between two or more entities. These relations can be of different types. Information extraction is the field of extracting structured information from natural language text. This field is used for various NLP tasks such as creating knowledge graphs, question answering system, text summarization, etc. Relation extraction is in itself a subfield of IE. The rule-based approach is an approach that is suitable for the type of IE The study is interested in whereas more complex information understanding would require more complex approaches.
Thank you, Tasfia Jahan, for giving me the floor. Hello, I am Shadbin Sharif. I am going to present the weekly supervised, supervised, unsupervised, and instantly supervised part of the relation extraction. So, first of all, weekly supervised relation extraction. The idea here is to start out with a set of handcrafted rules and automatically find new ones from the unlabeled text data through an iterative process like bootstrapping. Alternatively, one can start out with a set of seed tuples describing entities with a specific relation. So it has some steps like first of all starting with a set of seed tuples or extract a seed set from the unlabeled text with a few handcrafted rules, then extracting occurrences from the unlabeled text that matches the tuples and tag them with a namely entity recognizer, then creating patterns for these occurrences, and then generating new tuples from the text, and finally going to step 2 or terminating and using the patterns that were created for further extraction. It has some pros like more relations can be discovered than for regular rule-based relation extraction, and then it has less human effort requirement. It does only require a high quality seed, and it has some demerits too, like the set of patterns become more error uh, with each iteration, and it must be careful when generating new patterns through occurrences of tuples. And it new relation types requires new seeds which have to be manually provided. And then comes supervised relation extraction, which is a common way to do supervised relation extraction is to train a stacked binary classifier or a regular binary classifier to determine if there is a specific relation between two entities. These classifiers take features about the text as input, thus requiring the text to be annotated by another NLP modules first. Typically, features are context words, parts of speech, tags, dependency path between entities, tokens, proximity, distance between words, etc. So supervised relation extraction has some pros also, like the high quality supervision is one of them, which ensures that the relations that are extracted are relevant. And we have explicit negative examples, and it has some demerits too, like expensive to label examples, expensive and difficult to add new relations. It needs to train a new classifier. It doesn't generalize well to new domains, and it is only feasible for a small set of relation types. Then comes the distantly supervised uh, relation extraction. We can combine the idea of using seed data as for weekly supervised relation extraction with training classifier as for supervised relation extraction. However, instead of providing a set of seed tuples ourselves, we can take it from an existing knowledge base, such as Wikipedia, uh, Wikidata, Freebase, Yago, etc. For each relation type, we are interested in the knowledge base for each tuple of this relation in also the knowledge base. Selecting sentences from our unlabeled text data that match these tuples. Both words of the tuples is co-occurring in the sentence, and assuming that these sentences are positive examples for that relation type. Extracting features from those sentences and then train a supervised classifier on that. So this process has some positive sides, like it has less manual effort. It can scale to use a large amount of labeled data and many relations, and it has no iterations. It needs no iteration compared to weekly supervised relation extraction, and it has some demerits also, like noisy annotation of training corpus. Sentences that have both words in the tuple may actually not describe the relation, and there are no explicit negative examples. This can be tackled by matching unrelated entities, and this is restricted to the knowledge base and may require careful tuning to the task. And uh, and then finally comes the unsupervised relation extraction. Here we extract relations from text without having to label any training data, provide a set of seed tuples, or having to write rules to capture different types of relations in the text. Instead, we rely on a set of very general constraints and rules. So it could be argued if this is truly unsupervised, since we are using rules which are at a more general level. Also, for some cases, even uh, leveraging small sets of labeled text data to design and maintain the system. Nevertheless, these systems tend to require less supervision in general. Open information extraction generally refers to this parallelism. Uh, this unsupervised uh, relation extraction has some positive sides, like almost none labeled training data is required here, and it does not require us to manually pre-specify each relation of interest. Instead, it considers all possible relations, and has some demerits also, like performance of the system depends a lot on how well constructed the constraints and the rules are, and the relations are not as normalized as pre-specified relation types are. So that was all for me. Thank you for hearing us. Thank you, everyone.